The largest dam ever built by humans didn't just transform a river, it slightly changed the Earth itself. When China's Three Gorges Dam was filled, scientists calculated that the planet's rotation slowed by about 0.06 microseconds, making every day just a tiny fraction longer. The change is so small that no person could ever feel it. No clock on your wall could detect it. Yet modern scientific instruments can. At first, that sounds impossible. How could a structure built on a single river influence a planet nearly 13,000 kilometers wide? The answer isn't hidden inside the dam. It's hidden in the way our planet spins. And to understand how one engineering project could produce a measurable change to Earth's rotation, we first need to understand what makes Earth spin in the first place. The Three Gorges Dam spans the Yangtze River in central China, the longest river in Asia and one of the most important waterways in the world. Stretching nearly 2.4 kilometers across the river and standing about 185 meters high, it is the largest hydroelectric dam ever built. Construction began in 1994 and took more than a decade to complete, making it one of the most ambitious engineering projects in modern history. The dam was designed to solve several major challenges at once. It generates enormous amounts of renewable electricity, helps protect millions of people from devastating floods that have historically affected the Yangtze Basin, and allows much larger cargo ships to travel farther inland, strengthening one of China's busiest trade routes. But the feature that caught the attention of scientists wasn't the concrete, the turbines, or even the electricity it produces. It was the reservoir behind it. When the reservoir reaches full capacity, it holds around 39 billion cubic meters of water. That's approximately 39 trillion liters, weighing nearly 39 billion tons. Instead of flowing naturally downstream, that unimaginable amount of water is stored hundreds of meters above sea level in a single location. And although that doesn't sound like much on the scale of an entire planet, moving such an enormous mass is exactly what led scientists to ask an extraordinary question. Could storing that much water actually influence the Earth itself? To answer that question, we first need to understand a basic principle of physics. Earth doesn't rotate simply because it's spinning through space. The speed of that rotation also depends on how the planet's mass is distributed around its axis. A useful way to picture this is with a figure skater. When a skater pulls their arms close to their body, they spin faster because more of their mass is concentrated near the center of rotation. When they extend their arms outward, that mass moves farther away from the center, causing the spin to slow down. Earth follows exactly the same principle. The Three Gorges Dam didn't make the planet heavier. Earth's total mass remained exactly the same. What changed was the distribution of a tiny fraction of that mass. Before the dam was built, billions of tons of water flowed continuously through the Yangtze River toward the East China Sea. After the reservoir was filled, much of that water was held at a higher elevation, remaining in one place instead of following its natural path. On a human scale, the difference seems insignificant, but on a planetary scale, moving 39 billion tons of water is enough to slightly alter the way Earth's mass is distributed. That tiny redistribution increased Earth's moment of inertia, a physical property that describes how resistant an object is to changes in its rotation. As the moment of inertia increased, Earth's rotation slowed ever so slightly. The change was incredibly small, but it was large enough for scientists to measure with remarkable precision.